So let's start the class. So today we will be doing information extraction, and uh, a specific task in information extraction is named entity recognition. So information extraction is actually extracting of structured information from, we can say, from unstructured text or from a free flow text. So structured information is of the form having some kind of a structure such as rows and columns, etc. So we have this kind of structured data. So structured data is useful in databases. We store the structured data in the database, and then we do some kind of manipulation on that data, right? So this kind of data is called as the structured information. So this is structured. So I have some kind of web space in which I have, suppose this is the Twitter, or I have Wikipedia. So this Twitter is in the form of tweets, right? So these tweets are having some kind of information in it. So this has to be again converted into this structured form. So this is this data is quite noisy, and this Wikipedia is another example, but the data present here is clean. So in both type of these there will be different challenges, but the requirement is same. We need to extract the information in the structured form and then put it into later we can put it into the tabular form. So what kind of information could be present in this? There could be lots of information is actually the present in the form of nouns and the relationships between the nouns. So this Wikipedia article, now what is the use of collecting this kind of information? One example is that one application is that we can now pass on this structured information to some database or to some other downstream task. Another application is that we can use these identified pieces of information and then link them to their to other sources, right? So if I can so these things are coming later, again we will see again. So information extraction is actually finding and understanding the relevant parts of the text and gathering also the information from different pieces of text and then producing some kind of structured representation. So this is the structured representation. We need to produce some kind of structured representation of relevant information, and from that we can derive the relationships between different components. And we can link these kind of information to some knowledge base. So we can link the information to the knowledge base. So actually the goal of information extraction is to organize the information that is useful to some people or some task or application. And we can also put the information in semantically precise manner that allows other kind of algorithms to analyze and infer some kind of predictions from that. Okay, so we can use this data, this structured information, either to give it to some people, to some other application, as well as we can do some kind of analysis, some kind of forecasting and prediction with the help of this data, right? So we have these two goals. So information extraction roughly defining it as, so who did what to whom when. So asking these questions for a given piece of text, right? So who did what, whom, when. So who, when we say who, it is a person name, and when we say what, it may be some kind of event, and whom may be again a person, and when may be some kind of time, date, or some event, right? So there could be different kinds of factual information that could be present inside a text. So that's one thing that we can do with the information extraction. So like example of gathering earnings, profits, board members, headquarters, etc. from company reports. So there is a company which is having some reports generated from a given period of time. So it has to extract the earnings, and then the profits, the name of the board members, the name of the headquarters, right? So if, for example, the headquarters of BHP Billiton Limited, so this is the organization, this is the name of the organization for which reports have been generated. The global headquarters of the combined group is located in Melbourne, Australia. So this is the answer that is need to. So this is kind of a tuple in which this is the organization and this is the headquarters, right? Similarly, we can find out in medical or scientific literature or articles, we can learn information, we can extract information about drugs, about genes, about diseases, disease names, and lot of things in medical data. So we see here that this kind of the data that is extracted from some piece of text. So this is a kind of event which can be linked to a certain kind of another application, that is the calendar. And then we have this other kind of information that is present here, information which is linked to application or encyclopedia, right? So but this kind of information extraction is difficult to with information retrieval such as web search. So why we see that the web search does not, in this example, web search does not give us some kind of precise answer. We see that the best guess for BHP Billiton Limited headquarters is Melbourne, London. So we see here there is actually not one answer but two answers are present here, so Melbourne and London. So you see web search or information retrieval is not an answer to the information extraction. So in another piece of text, in some advertisement, you can see that lot of information is present here. So from lot of advertisements, some person may be interested to not manually see the advertisement but use some kind of automatic task to identify the intended thing. So you see here there are again the names present here, right? So you see a lot of information is present here. So this kind of information has to be extracted. So a subtask in information extraction is the named entity recognition. So information extraction is not a single task but is actually supported by the downstream task or a subtask, that is named entity recognition, and another subtask is relation extraction. So specifically we can categorize information extraction as the combination of named entity recognition and relation extraction. So we will see these two in detail. So named entity recognition is actually to find and classify names in a text, right? So whatever text we have, we do have the names there, right? So name is actually a kind of entity. So entity is what? Entity is something that is having some physical existence, right? It is having some physical existence, and it's also some kind of discrete or countable in nature. So it's discrete in nature. So there are a lot of entities present inside in this world. We have I'm having a computer in front of me, so computer is an entity, but computer is not a named entity. It does not have any specific name. So we are primarily concerned with those entities which are identified with certain names, and in these named entities we have the most primarily or the most common named entities. Common named entities are person names, or we will see them later. Person names, organization names, and time events, and location names. So these are very popular and common entities. So we see that this Andrew Wilkie is a person name, right? So this is an organization. This is a person name. This is an organization, and these are again the person names. And this is, we see that this is a date. So these are actually the four basic named entities that are generally identified in a named entity recognition task. So in any of the named entity recognition task, we need to basically or primarily need to identify the person, date, location, and organization, right? So there could be other entities also. We can now categorize the persons into subcategories such as celebrity and politician and different kind of entities we can have. Similarly, we can categorize this organization into, let's say, government organization or a private organization. So we can now do all these divide all these type of entities, named entities, into subcategories. Similarly, for location we can do like city and country, city or state, country, village, etc., etc., right? So this problem could be more is more kind of enhanced by using the fine grained named entities. So named entities are actually applied, again we see that they can be linked off or they can be indexed off to some other application or some other encyclopedia or some kind of website or web page, right? So we could also need to identify in say Amazon products, the reviews of in the reviews of Amazon products, we need to identify what are the product names, right? So names of products for which sentiment has to be extracted. Names of products have to be extracted for which sentiment is being calculated for sentiment analysis. Similarly, we can identify this we did that we can identify relation extraction between different entities. So a lot of information extraction relations are associations between the named entities, right? So a person could be an employee, or it could be working at some place. So there could be in a single piece of text there could be relationships between or associations between different named entities. Similarly, for question answering, answers are most often named entities, right? So in any kind of language processing task, this named entity recognition could play a significant role and enhance the performance of that task. So we see the applications here. Many of the web pages tag various entities linked to the bio or topics. We have already seen that in news websites like Reuters and other ones. Yahoo also, we see that some link is highlighted and that links to the bio or other topic pages, right? Similarly, there are in Microsoft, Google and Apple, they have these smart recognizers for document content. So they actually identify some kind of entities in those documents. Now, what is the how do we define the task of named entity recognition, or what is the problem statement? So we have a free float text like this, and we organize that text into a sequence of words. Say for example, foreign ministry spokesperson Shen Gufeng told Reuters. So we do, first thing is that we annotate each of these words. We annotate these words. So what kind of annotation is? We annotate these words into the organization, person and location, and say time or date. So first we need to extract the data in the form of tokens at word level, and then we need to assign the respective named entity token, and the rest of these apart from all these tokens, org and person, the left out tokens are annotated with O, that is others. So the standard kind of evaluation or annotation or labeling or prediction is one is per entry and not per token, right? So we see that this combined these two are actually an entry. Similarly, this combined these two are actually an entry, and so per token is not actually or of that much significant, but we see that per entry is more significant, because maybe 2 entries or maybe 3 entries of a token may lead to a named entity. So this collectively is actually an organization. And this collectively is a person, right? So these things to have to be taken care of while solving the task. So we have different kinds of approaches in which we could have the handwritten regular expressions, and then we can have generative or discriminative classifiers, and then we can have sequence models. So the regular expressions may be of some kind of writing some kind of regular expression or regular automata, so that automata is able to process the string and identify whether that string belongs to a particular class or not, right? So for web pages we can apply some kind of regular expressions in their in their code by reading their code. So this is, we can apply these kind of regular expressions, and then we can also apply the regular expressions in case of the words or tokens. So for identifying the phone numbers, we can apply these kind of regular expressions and patterns. But such kind of handwritten or regular expression based approaches are called as rule based approaches. We follow some kind of rules. So these rules may always not be very well defined, because rules or things change with time and domain. So the phone numbers may be working having some pattern for some country, and it may be having some other pattern for some other country. Similarly, this web page may be having some pattern for Amazon, and it may be having some pattern of the or Facebook or some other Twitter web may be having some kind of different patterns. So in order to generalize, these handwritten rules or handwritten approaches are not very workable. And practically, when when this task was identified as a significant task somewhere around in 1990s, and, and near about 2000, so at that time these rule based approaches were very important. But currently we have a lot of machine learning and powerful algorithms, so that work quite well on these kind of tasks. So there is one more kind of rule based approach, that may be some kind of matching between different entities, or kind of having uh, uh, or having some kind of identifying or matching some kind of relations or associations between between different named entities. For example, we have a person or office of organization. So this of is can be used some kind of uh, an association, right? So when we see that it is the of is appearing between two tokens, then the preceding and succeeding token may be some kind of entity, right? Similarly, the word named, appointed, etc. So these are significant words that can be identified within a text manually, and then they can be some kind of rules may be written in order to identify the entities, right? So again, as I told earlier, that these rules are not very are present in specific domains, and rules change with domain and with time. So these kind of approaches are not very practical. So the most successful kind of approach could be using some kind of classification technique or text classification technique for extracting names in a given piece of text. So we all have seen what is text classification, and how do we apply text classification. So we can use any kind of text classification. We can use naive Bayes logistic regression or any kind of classification algorithm. So what we need to do with the text classification algorithm is that we need to organize our data in that form which is readable for a text classification algorithm. So what we do is that we extract the data from the we extract the relevant information, and then process it into a kind of data set, right? So this is actually another example which is related to the information extraction, but not actually the information extraction. It is actually identifying the change of address detection in some kind of emails that are obtained that are received in an organization. So this is a kind of classification task. So in named entity recognition task or information extraction task, what we need to do is that we need to again collect the set of training documents, and then we need to label each of these tokens into their entity class or into the class and the other class, and then we need to extract the features, and then we need to train the classifier. This is the traditional machine learning framework that we need to apply on any kind of problem, right? So this was a small example of again a machine learning task in which the change of address has to be detected. So the relevant information is from an email is like extracting the from the content of this from field, the content from the subject field, and extracting a little bit of the part of the starting of the email, right? So these could be extracted, and then for different emails they can be compared with each other with some kind of similarity measure, and then if these two addresses are similar to each other, then they can be said that it can be said that these two addresses are same. Otherwise, if these two addresses are different, then it can be specified that the address has been changed, and this changed address can be extracted or can be delivered to the person concerned, right? So in this way, in a similar way, we can proceed with the named entity recognition task. So which is pretty easy. We can again have this kind of say free flow text, and we can mark the labels of each of these tokens. So we have two kind of annotation schemes or encoding schemes in which we can mark the tokens and add and annotate them. So one scheme is that we just use the label names of person, location, and organization. So in this scheme we have the token names, the label names as location, person, organization, and we have this O. Right, so we can specify all these tokens with these three or with these four labels. But in another IOB encoding, which is inside out, inside outside and beginning encoding, so this which is inside and other encoding, so inside, other, and beginning. So this the B person actually specifies the beginning of the entity, and this specifies the intermediate part of the entity. I specifies the intermediate part of the entity. So in this IOB encoding we have I LOC as a label, we have B LOC as a label, then we can have two for the person, I per and B per, and similarly we can have the same for I org and B org, and we can have the O as the label. So we have 1 2 3 4 5 6 7 labels. So here the number of labels is actually the number of, and depending upon the number of entities we are marking in, which is equal to, in this case it is, if we are having three named entities, we can have we can have it as named entities plus 1, so NE plus 1. But here we have the number of labels as twice of named entities plus 1. And some people have also proposed the IOBE encoding, which signifies this is the intermediate part, this is the beginning part, and this is the ending part. Right. So in this case we can have three of the named entities plus 1 labels. Right, and people have used these encoding schemes and found that these are perhaps a little bit more efficient, giving more good results than these two encodings. But the problem with these IOB or IOB encoding is that they will obviously take more training time, as there are more number of class labels present there. Okay, so this IOB encoding, IO encoding is actually fast, and it works quite well. It works, the performance is quite well, so works very well. So why it works very well is that we require these kind of the different these intermediate or beginning or ending of these entities, because we need to identify from where the entity is beginning, right, or where the entity is ending, and why. And this is relevant because it is suppose at this we are having two entities. This is, sorry, this is I. So suppose there is in some example two of the entities are appearing just next to each other. So this Fred is a person, and like it's in case of some example, say this also is appearing next to the first entity. So this is the first named entity, and I'm marking it as a PER, and this is the second named entity. I'm marking it as a also as PER. So in this example, we see that these all of these separate entities, or both the separate entities are marked as person. So the classifier will not able to identify whether this is the same entity or this is the different entity, right? But we see that this is some kind of very rare in that happens in kind of in the corpus. In so generally we would have some kind of token between these two entities, like comma, like some kind of conjunction like and, or some kind of joining or associating words like with and other kind of some kind of words that will be present between them. So this kind of situations are very rare in case of clean text, right? If we are having some kind of scientific articles or Wikipedia articles or some kind of reports or newspaper articles, so these kind of texts are very clean, and in which we don't have these kind of these scenarios are very rare. But when we have some kind of informal or noisy text, so in that case we could have these we could see that these kind of scenarios and these kind of cases are very higher in number, right? So we need to see that when we are applying, when we are solving the task that is related with some kind of clean text, so we can do it very easily with IO encoding. But when we see that we have the task that is related to us is related to NER is based on some kind of noisy text, so we need to have some IOB encoding or IOBE encoding. And perhaps the medical text is clean, but it has some kind of different kind of challenges. So IOBE encoding is quite successful in medical text, identifying the protein names, the drug names, etc, etc, right? And the second thing is that this kind of the consecutive entity problem can be easily resolved by the sequence models. So it depends upon the problem which kind of encoding we may use, right? So this encoding is important because before going to actually classifying training a classifier, we need to first give the labels, and these labels have to be specified manually. We don't have any other option, right? So we need to acquire the text and then tokenize that text, and then after tokenization we need to see manually which of these tokens are person, which of these tokens are locations and organizations and others. Okay, so before training the classifier, we need to again, once we have this kind of with this kind of data set available with us, we need to extract the features from that data, and then we can apply those features into any kind of traditional machine learning algorithm or sequence labeling algorithm. So the most basic feature could be the word itself. So in each of these instances, each of these will be acting as a training example. So this Fred shows you Mengui. So each of these itself can be a feature, right? So we can have these words as a feature. and apart from these word as a feature, we can extract the previous word that is linked with the target word, and then we can, if we are having some kind of part of speech tags, then that would be quite helpful, right? Similarly, we can have some kind of label information and attach it with in the feature. So these kind of the words as a features are significant, but we need to again go inside the word and identify some kind of orthogonal features, and that some kind of characteristics features inside a word, instead of just having the simple word as a feature. So we do is, what is that, we identify the substrings. We can have the different substrings like character n-grams. So we can have character 2 gram, character 3 gram, etc., and then we can extract these substrings from a given word, and then that would be quite helpful, because there are specific kind of patterns that could be found in the substrings, like this OXA may be found in some kind of drug, right? So this is the maybe this kind of 3 character gram may be very common in a drug name. Similarly, Weathers field is again this kind of field may be important or significant with locations, right? So this is, the field is present in some kind of data set. If it is related to locations or places, we see that this field is requiring large part in that space, right? So we can have different kind of effects of the substrings. So this is a significant feature in respect of the named entity recognition. Similarly, word shape is another kind of a feature. So what is word shape? Word shape was defined by Collins some way back in 2002 or 3 or 4. So he said that we can identify what is the shape of a word, and with the help of that we can use it as a feature. So that actually categorizes different words into shape categories, right? So he said that we can replace each of these characters, each of these alphabets. The capital alphabets can be replaced by a capital X, and small alphabets can be replaced by a small x, and the decimal numbers can be replaced by a decimal, by a D. So this is capital letters. So it can be replaced by capital X, small letters. Small letters can be replaced by small x, and then some numerical numbers or decimal numbers can be replaced by small d, right? And a sequence of anything of any of these above can be represented by hyphen. Right, so this, in this first example, we have a capital letter which is starting, so we have this, right? And then we have these lot of small letters are there, so that they can be represented by this hyphenated small x, and then this last one can be represented by with this. So we can now now define different kinds of shapes, right? So this, you can see that this in the second example, this is actually a protein name, and this would, all the proteins would have mRNA, and other proteins would have similar kind of shapes, right? Similarly, drug names would have similar kind of word shapes, and this is varicella zoster is again some kind of specifically domain related name. So these shapes could be identified, and they can be discriminated by the classifier with the general names, right? So general names may have some simple patterns, okay, and these of some kind of special names may have some complex shapes, right? So these word shapes can also be very useful in named entity recognition. So once we get these features, we can simply train a classifier. We can do, what is that, we can again have these, we have this kind of the data that is available with us, that is in the form of the names and labels. We have these tokens and labels. So we had this example Fred showed. So this is again, Fred is a person and showed is O. So we need to convert this again, extract tokens from extract features from these tokens and convert it into a feature set. So this could be again this kind of so we can have some, say suppose 2 gram features. So this is 2 gram 1 and 2 gram 2, and you can have some kind of 3 gram features, 3 gram 1 and 3 gram 2. So we can do, what is that, we can, from the whole corpus we can extract the 2 grams, and then we can have high frequency 2 grams. So suppose we have a k number of 2 grams, so we will use these k 2 grams as features. Similarly, suppose we have p number of 3 grams, we will be using these 3 grams, p 3 grams, and then we can have the shapes. So we can encode all these 2 grams and 3 grams, and then whether we see that that particular 2 gram is present in this token or not, we give a code for yes or no. So if it is present, yes; if it is present, no; this present, yes; this present, no. And the shape may be of some code, say C1 and code C2 and code C3. So this is, this kind of data set can be obtained from this tabular data, right? So once we get this kind of data, we give this data to a naive based classifier. We do have the classes present here. We do have these classes. So this is the class. So the class is the person O, person, like this, and then we use this to train a classifier. We give it to a classification algorithm. So algorithm could be naive Bayes, logistic regression, or SVM. So this gives the model that will be used to predict the labels for a new data, right? So in this way we can simply use the traditional machine learning algorithms and train them with the help of this kind of encoding schemes and having extracted features from the table, from the tokens.